At AV&R, our mission is to humanize robotics. We decided to create this podcast series to help you demystify the world of robotics and discover what some of the brightest minds in the field are doing. Welcome to Robotics for All Podcasts by AV&R.
I want to introduce two great 3Mers. Nathan Herbst is a senior robotic application engineer focused on automation applications for transportation markets and force control technologies. And Scott Barnett currently leads the 3M Global Abrasives application engineering team that is focused on engineering of robotic abrasives processes in collaboration with system integrators and end-using customers. In this episode, we compare notes on the best ways to solve finishing problems, the wide variety of language used to describe these processes, and the detective work required to find the best path to success. It was a fun conversation. These guys have seen it all, and hopefully there's some good pieces of advice for everyone looking to adopt robots. Hope everyone enjoys the show. Here we go. Hello, guys. Thank you for joining me.
Well,
thanks Michael. Mike. Great to be here.
Yeah, so by this point, we would have already introduced you, so we'll jump right in and have some fun talking about some customer conversations and see what, get some of your opinions and talk about some of the fun, tough stuff that we've gotten into over the years of looking at finishing systems and dealing with a wide variety of applications, which I'm sure you guys see, being with 3M and the wide variety of products you have. I'm always amazed, when I jump into your website or I get on the phone with Gabby, just the quantity of products that you have to help people and the depth of expertise you guys have. So I think this will be fun to prick your brains a little bit about it. So, the first thing that we had talked about in customer conversations, do we get in our own way when we're talking about applications? So let's say a customer calls you up and, how do we approach it? And we have our preconceived notions. They've obviously got a way that they're usually tackling it, often for many years. How do you guys like to do it? Have you found it better to start with, what's a customer doing now, or is it better to try and go with a clean sheet of paper? What are your guys' thoughts? What's been the best way that you found to approach an application?
Maybe Nate, I'll take that one first. Sure. And you can add some comments. Yep. Obviously we participated extensively in both, and it's so natural, I think, for somebody interested in automating a process to go first take a look at the current process. I do feel like when you naturally constrain your thinking a bit to the inputs and the outputs of the current process, and perhaps you aren't thinking big enough about what automation can really do for you. So I do think, Michael, at times we do get in our own way when we know too much about the current process, and it's often helpful to back away from that and just talk to the customer about, what are you trying to accomplish? What are your biggest problems and challenges? What do you get the most value from? What are your incoming parts look like? What are the requirements coming out? And, we would love to take advantage of all the benefits of automation, including things like consistency of robotic processes, potentially speed of robotic processes, ability to apply a lot more force, run things faster, hold heavier parts, etc., and take advantage of those things. And in many cases, totally change the process, change the abrasive form that's used, etc. So when it's possible, I think you get the best value when you do that versus simply replicating a manual process. And I'm sure Nate's got some examples or comments he can add.
Yeah, I completely agree. No, I like to see the process to at least understand what the end product has to look like, or at least an idea of what the requirements are. Sometimes it can be challenging depending on who you're working with. They may or may not have defined requirements for what the process has to look like to go on to the next step. And it sometimes, even if they have a defined requirement, there's a way that they do things today that may not necessarily follow that requirement, but they expect it. A good example is there's a company that was making steel shafts, and their minimum requirement for plating was a certain RA. Well, if you met that minimum RA, no one would pass it. They'd run them back through again because they didn't think they were able to be plated. So understanding, and I don't want to constrain the process with it, but that's just one example of unwritten requirements that the people that run the process that understand it know it well enough that you have to be able to kind of derive that from discussions with the people that are running that process. To Scott's point around, you don't want to get hung up on how it's being done today. A good example of that would be fabricating large cylinders. Say those could be for brewing, they could be for pharmaceutical, they could be dairy, what have you. Historically, those are welded and then ground down using hand tools by operators. And these operators are pretty good at what they're doing. They're stainless steel usually, but they have to try to make as minimum of a rotary mark in that part and then go back and finish it in a linear fashion and blend it out. Now with automation, you have the ability to, you don't just have to put a conventional hand tool on the wrist of that robot. You can put a much larger piece of equipment like a belt back stand. A robot can pick the whole thing up. So we could pick up a couple 100-kilo belt back stand with a 132-inch long belt and bring it to that part. And then you have, a much longer cycle or a much longer abrasive life, which, if you've got a large part, you could have to change your abrasive multiple times throughout that. So if you can get to the point that you can, say extend that by 10, 20 times, that's that much cycle time just in abrasive changing that you can save yourself.
Yeah. There's a couple interesting points there. The first one that kind of rang in my ears was you talked about what I call the tribal knowledge and kind of get to that. So on paper, it might say one thing, but in the organization, you've got your quality inspectors, you've got your finishers. They know what is the practical target of getting to. So, and I call that the tribal knowledge of the organization, where it gets passed down from finisher to finisher as they bring in a new guy. That's part of the training, a new guy or girl, and that's part of the info that they need to pass along. So trying to capture some of that, and sometimes that leads into the practical touch, right? So on paper it says this, we can hit it, and then there's that practical touch that kind of rounds off the corner, so to say, that makes that application a home run if you find that right sweet spot for the automation. And then the other thing too that I noticed, and I noticed that as well, where the companies that we often talk with, they're used to finishing it by hand for so many years, and they aren't aware of some of the tricks that you can do with a robot. So being able to apply a heavy force consistently over time, that'll wear a person down. So they're going to avoid it, or they're going to change abrasives, or they're going to come in with a different combination of things. But when you throw it on a robot, all of a sudden the tack times, you can realize, are much faster because you can apply those heavier forces over a longer period of time. So, teasing out, okay, what's going on, and then where the game changer is for those processes. That's pretty interesting to try and find. You have to play a bit of detective.
Yeah, there's also to the point of what robots can do beyond just lift heavy things. They can operate very quickly. They can operate in perfectly straight lines. They can do a lot of things that people can. So all of those little tricks that a robot can successfully do, if it's a matter of swinging through an arc accurately and very quickly, a robot could do that, where a person time and time again is going to be off. So yeah, those little programming tricks and pathing things you can do with them is impressive as well.
Yeah. And then, we're technology guys here, so we talk about the path and stuff like that. So sometimes, and we'll get into some language of different processes, but the way you talk to a customer about that, getting out of our technical jargon that we live in every day and relating it to the customer so they go, oh, okay, and taking so that if they're sitting beside you or they're tuning the robot, they're going to take it sometimes a lot further than we can, just because they understand their parts so well. So unlocking that potential too. We spend a lot of time talking about that here and finding different avenues and making things simple in a robotic world for people that are used to the finishing, for that are used to those making their parts. Now, when someone, people listening to this might be trying to get into robotics or might be trying to discover, okay, what's in it for us, and maybe they've got a whole list of questions. So, when someone's looking around the internet and trying to understand, okay, is this right for me? And maybe they'll decide, you know what, let me give a call. And they call your robotics center, or they call us. In your mind, what background information should they have about before they call? Just to help them out, just kind of boil down and have a good conversation and kind of understand what's the lay of the land.
Yeah, I've got a couple comments there, and then Scott, I'm sure, can chime in. A big thing that I think people need to understand, it depends on who it is, because what I see is, and I talk to most of the time, is engineers. Engineers love to look at their existing process and try and figure out, okay, they're tasked with making it better, making it more consistent, making higher throughput, higher volumes, whatever it is. And engineers can look at that process and think, automation would be the key to do this. Let me talk to somebody about automation and see where we can go from there. The challenge with that is, as I see it at least, is you could start going down a path with that engineer. Unfortunately, they may not have buy-in from their management or their higher level engineering managers, or even the VPs that have to sign off on this stuff. So I think it's important that discussion at least be had around, is it in the cards? Is it possible at all that we can look at automating this process? And then once at least those people are contacted and they have at least kind of a preliminary understanding of what sort of capital expenditure might be involved here, and the engineer tasked with it may not really know yet, but understanding, or at least those key stakeholders, that they have at least some understanding that there will be a capital expenditure here to do it. Maybe they don't know what it is yet, but getting their buy-in is important.
Yeah, that makes a lot of sense. And the world has changed so much. When I first started into this market, it was, what, I think we can do that with a robot. Now it's, okay, we can do this. Now finding the right line between that practical touch and it being a high-end adaptive system, that's the conversation. So you're absolutely right. I think people can be reassured that this technology's come a long way, and when they pick up the phone, there is a solution waiting for them on the other end.
Yeah, I think that, Michael, you hit the nail on the head in terms of the, getting into, really sophisticated processing, like, adaptive processing and those types of things, which inherently are much higher cost. We also see, people, ultra concerned about, the cost of a robot itself, et cetera. And of course, we all know that really the price of a robot is relatively minor compared to the overall cost of an integrated cell. And it's about choosing the right robot for your operation, whether it be, payload requirements, reach requirements. Today, we have a lot of people asking about collaborative robots versus industrial robots. And so, walking people through their application helps us drive to what is the right solution. But, it's really not about the cost or the price of a robot. It's really about all the other things that go into an integrated cell. The other thing we see a lot, and because we deal, Nate and I deal extensively with robotics, but within our careers, we've done a lot of other things as well: fixed automation, manual processing, et cetera. And in some cases, it's better to actually use a feed-through piece of machinery, fixed automation, not robotics, because your part's simple, simple geometry, simple requirements.
super high volume.
Super high volume. A lot of things would point you toward fixed automation. Even though you could do it with robotics, it still might be better to do with fixed automation. So some people are locked into robots because, hey, they're the future for a lot of us. But there are good ways to do it without robots. And in fact, in some cases, you can use robots to tend the fixed automation grinder or sander or whatever. It could feed parts, it could pick up parts, etc. So it's not that you may not use robots in the operation, but may not use them to do the abrasive process itself.
Yeah, yeah. You know, we're having a lot of conversations too. You mentioned cobots, and you know, it's kudos to the companies that have come up with the cobot and their marketing, because they've created quite a buzz, you know, and there's a promise to it, right? The first promise was, you know, they're letting the robot out of the cage, you know, and that's going to change the way everybody works. And then, you know, there's good and bad to that. And then the next thing that came up is that, well, actually they're a lot easier, right? What have you guys kind of unlocked with that? Is, you know, in the finishing world, what's the promise of a cobot for you guys?
I think go ahead, Scott, maybe you can jump on that one.
Okay, I'll go, and then obviously Nate'll have some perspective too. You know, a very common question and discussion, Michael, as you noted, and we work with collaborative robot manufacturers, and we've done some recent work to try to understand within the range of abrasive processes, you know, where are they really most viable and where are they less viable? And in general, you know, collaborative robots, because they typically are relatively low payload, you know, generally short reach, and in many cases, probably for a lot of abrasive applications, especially with the abrasive in hand, the process at the wrist of the robot, need additional safety protection, like area scanners or cages or whatever anyway. That in many cases, perhaps they're suitable, but less differentiated than industrial robots, especially versus industrial robots, especially for applications that are lighter duty. So random orbital sanding or orbital sanding is probably the most common one you see people using collaborative robots for, but you could do some light duty finishing, some light duty deburring, etc. But when you get into grinding, that's where often you need higher payloads. You need, in many cases, more stiffness, and depending on the part, you know, you can use longer reach. So it really does depend, but we see them at the lighter duty end of things, and obviously, you know, that limited in terms of the type of equipment that you can put on the wrist or the size of the part that can go in the wrist as well. But in general, you know, our comment is always do a risk assessment no matter what. We definitely have seen people that believe they've been able to deploy them more quickly than an industrial robot. That is definitely some of the input we've seen. But there's a lot of companies working on democratized software for industrial robots as well to make them easier to program. And so, you know, they're out there. And they're just starting to get used really for abrasive processing, but we do see them generally at the lighter duty side of things. Nate?
Yeah, the ease of programming, I think, is the real shining point about them right now. The thought being that you could have a cobot that you could move into an area for, you know, I see it in the lower volume side, maybe one-off applications where somebody could teach based on a master part. You can physically grab the end of the wrist of the robot and pull it and then save your points pretty easily. So for complex geometries, you can save a bunch of points simply. And if you've got a small run of parts to sand or something like that, you can do it. I think the challenge with them is, you know, outside of the payload and reach is the speed. And that's something where if you've got high volume, if you've got a lot of parts flowing through there, the time that you're not contacting the part, industrial robots can move at 2,000 millimeters a second. They can fly. Whereas these are limited because they're limited on the amount of energy they can provide. So they can't get out of the way as fast. They can't transition parts as fast. So you're leaving cycle time on the table. And if you're doing, thousands of parts a day, a week, a month, and you leave seconds on there every cycle, you're leaving cycle time out there. So I think that's one other challenge that I've seen, because that's been a comment around, say, work that I've done around, how we move in our lab, because our lab is just purely for prototyping. And historically, we haven't ran in auto mode for a lot of they're industrial robots, but we don't run them at full speed. So, and then people come in and they might get the impression that that's as fast as it can go. And then we like to show videos or show something else that, okay, no, this is only because the environment we're in. But an industrial robot, if you want to, look up some videos, you can show how quickly these things can move around. Yeah. And then that can really impress people of, okay, I like what it can do while it's sanding, but all this extra time around it, I don't want to invest in, my hundreds of thousands of dollars in having the robot just cycle through the air that.
Yeah.
So I think that's a big miss that, and I shouldn't say a miss, but it's a limitation of collaborative robots.
Yeah, I don't know. With the safety standards, I'm not sure that there's much they can do around that. Mm-hmm. Maybe there's, when you really want to be truly collaborative, right, as a robot beside a person, add safety scanners and stuff like that. And then you're starting to get into the realm like the CRX, the Fennec. It's got a couple different speeds that you can change the limitation based upon the safe environment that you're set in. And, when I talked with them, they say, there's going to be a future where it's not, is it a collaborative or a traditional robot? It's just going to be how you implement it, right? Yeah. So, and how you take care of the safety around it. But so, and you want that collaborative environment. I think my opinion right now is, there's going to be a speed limitation, and that's just all in the way that you put it, how close you put it to people, right?
Yep.
I think that's
to the point that you can, based on how it's installed, adjust that.
Yeah.
Then, that'll be important. But then I guess I question if the ultimate install is designed to be away from people and separated, mm-hmm. What's the benefit of it?
Yeah, I think we have a lot of customers asking us about collaboratives. As I mentioned earlier, and some very large customers, and I think it is built around more that they really want that human intervention into the process, and so in their mind, the collaborative enables the human intervention nearby. But we do encourage them extensively. You need to do that risk assessment because. Mm-hmm. Depending on the operation you're doing, you simply may have to still protect the humans more than just with automatic controls put in place by the collaborative force and speed limits. So just something to be considered. But I do like the concept that we're just going to have robots, and it's just how you integrate safety into their process, whether it's integrated with limits on speed and force capability, or whether it's integrated with scanners and cages, or a combination.
Yeah, and it shows that things are only going to get easier too, because one of a common theme we see is it's a gateway robot too. So a customer that is interested, they've got a team internally, they're pretty good, so they're going to say, you know what, we're going to try it ourselves first. And I've seen a few grab a collaborative, give it a try, and they find the limitations pretty quick, but they do a good job of it. And that's due in part to some of the ease of some of the software. You'll reach your ceiling pretty quick on when you get into the more complex stuff. And then they come back, 6 months, a year later, and say, okay, you know what, I get what you guys are doing. I tried it. This is where I ran into problems. Now let's talk about what a real production system would look like. So it's a great learning tool as well too for organizations, and I encourage it, especially organizations, some of the smaller ones, they got to do it themselves too, just to try and get above the status quo. So, you'll have some guys internally that say they think you can get it done, and that helps the organization innovate. It helps them, get to the next level too. So, it's been a good. I think there's limitations around it, but it's helped stimulate the conversations and the market as well too.
Good. I hope that, like I said, you've had people use them as a gateway robot. Just hope that they understand that there's more that can be done beyond, with the capabilities of industrial robots. What, as long as they aren't limited by, okay, this is what we believe robots are capable of.
Right. Yeah.
I guess it's important to ensure that they know there's things beyond that.
Yeah. And that's where conversations like this and the content that we build working with customers, I think that's important. Your labs that you guys have around the world, that's important to show, what's possible. And the world, it's fast moving. So every day there's new tech coming out that helps us. One of the things you talked about was the tack time, the cycle time, and that's the second question that we always get, right? So the first one is, can we do it, right? And we've got the lab set up together. So let's say we process a part, we show, yeah, look at this quality, and they go, okay, that's great. So how fast, right? And that's always a fun part, because it's the trade-off, that practical touch between over quality or extensive inspection versus just getting the job done and making sure you're hitting that tribal knowledge. So how do you guys approach business case, and what are the common themes that you see for justifying a business case and helping that engineer bring back to his VP or her VP a viable project?
But we've got, there's some tools that we have available through our website for an ROI calculator. Helps you consider some of the costs and you've got to make a lot of estimates on your own, and that's where maybe it helps to work with somebody who can give you an idea on what some of the costs involved are going to be. But it can help you look at all of the costs that are on your side. A tough part of the ROI side of the world is looking at a manual process, counting up the number of operators, what do they make per hour, and using that as your number. And that's, you're leaving a lot of meat on the bone there when you do that from a ROI standpoint. Not to say that's maybe these people are going to get absorbed into other areas, so these costs won't go away, but you can, if that labor is going to move, that they're not billed into that process anymore. There's the hourly rate for that person, but there's insurance, there's workman's comp claims from cuts and nicks and things that can happen during these processes. With the abrasives, you're cutting, you're grinding, you're removing material, and it happens, accidents happen, and people get hurt. So there's costs associated with that. Also, your scrap. If somebody had a bad day, somebody wasn't paying attention, can they gouge something, damage something? Okay, that part's scrapped, or it's got to spend time to be reworked. Robots don't do that. So trying to understand all those other costs that we can loop in to help justify the robotic cell. It's important to make sure that all those are accounted for.
I think it's pretty common for people to under leverage the opportunities in an ROI, because to Nate's point, he identified several things that are tough to quantify. And I can tell you at 3M, you can't make, it's hard to put all those soft things in a presentation to the finance person who is going to support your investment request. And often we'll find that we just simply bypass some of those softer savings, but a lot, in many cases, that's where the big meat is as well. And I think one other thing to consider is, especially in the environment that we've been in the last several years. Labor shortage in a lot of countries, and thereby constraining throughput for a given customer. So they just simply can't get enough labor to do the operation. And so when you think about a constrained environment, either where you just don't have productivity to get as many parts out as you have orders for, or you simply can't get enough labor. In either case, in some cases, just being able to increase throughput and gain substantial revenue can be a real big driver as well.
Yeah. When we
cost of training new employees, and that's huge to get somebody that's finally good at it. I mean, it can be months, and then that employee gets good at it, and they get sniped away by a competitor, and then you're starting at square one again. With a robot, that's not going to happen.
Yeah, that tribal knowledge is hard to pass along. You have to stand beside each other for a long time to pass some of that stuff along, right? And have the skills and the dexterity to do it. So we also have a calculator too that we work through with customers, and sometimes they like to do it on their side, and there's different dynamics that you get in that conversation, but certainly the throughput in gains in throughput, to me that's like throwing gas on the fire. That's really where you get a lot of benefits. So whether your challenge is finding skilled labor or meeting a ramp up, if you've got additional production coming through your facility, that can really accelerate a business case. Now in this pandemic world, we've seen a little bit the shift in what is a reasonable business case, right? So if somebody's looking, and they want to make a home run to pitch to their management, what are some of the numbers that you guys have seen? Is it 1 year? Is it 18 months? Is it 2 years acceptable? But what type of business case should people be targeting?
I think it's pretty common, Michael, for 2 years or less to be the target. And I would say for good, successful deployments, it's not uncommon to see less than a year return. Really depends on the business environment. And to your point, it's been a little thrown sideways here over the last year, although it hasn't reduced the need to automate, actually increased the need to automate, dealing with, separation of resources, et cetera, due to COVID. But when you really get to return, I think generally 2 and less is what's targeted, with, as I stated, quite commonly coming in under 1 that we've seen in some cases. I don't know, Nate, if you've seen, ones much higher than 2 years. I'm sure they're out there, and I'm sure they're justified.
Yeah, I mean, there's
some harder.
Some of the real big, the massive installs can get pushed, but it's for the 1 or 2 robot cells. Yeah, it's in that 18 months and under.
Yeah, that's typically what we see too. That's kind of it's been the sweet spot, and it's important to, I never underestimate the internal sales that our customers have to do, right? And they have to turn around and, put their name on the line and say, this is what we're going to do. It's going to help our organization, and that's typically a target that speaks to a lot of the management, and it's a good way to position it.
Like Scott mentioned with the recent health issue, if you can't get people to your facility, you can get robots there. I mean, granted, you might need some people there to feed parts to a robot, and not to say that they're going to solve everything for you, but if you've got space limitations, or you've got people that can only be so close to one another, it's easier to do when you have robots doing a lot of that processing. Mm-hmm. So it's another benefit, which I would expect could work to push that ROI requirement out a little bit.
Now, you guys, how many labs do you have set up helping customers with robotics?
Yeah, we've got 14 labs around the world, supporting customers, with proof of concept work,
Yeah.
basically through our application engineering team and our partner application engineering team.
Okay, I had to ask because it's growing, and I'm amazed with your guys' commitment, and it's amazing that how you're getting behind robotics. Now, having those 14 centers, I'm imagining, there's a lot of discussions, a lot of talk, and you see applications from all areas of the world. So let's talk a little bit about language, and what. When we speak with customers, sometimes they'll say polishing, and then when we dive into it, they actually mean deburring and stuff like that. So it creates it's part of the detective work, and it's fun, and I'd love to just walk through some of the big processes and hear what it means for you. And, it's kind of funny because when we were sharing the notes, getting ready for this, I said slang words aloud, and I went on the Urban Dictionary, and you know what? I'm not bringing any of that to the conversation. You went to.
Thank you for that, Michael.
Yeah. So I was hoping to have some good material from that, but we'll leave that for another talk. Okay, grinding. For you guys, what is grinding?
For us, it's coarse abrasive, 36, 40, 50 grit range type of work. Normally, it's knocking welds down, taking gates down. That type of work. But then there's also the bonded wheel type of grinding. So people that are still similar applications, knocking off weld flash, beveling, heavy material removal, I guess is maybe the most generic version of grinding. And the products that are associated with it.
Have you heard any interesting names for it that outside of grinding, or is that pretty common for someone to come and say, I've got a grinding application? You're like, okay, let's talk about that.
That one tends to be pretty well understood. Snagging or knockdown, there's other terms that can be thrown at it, but it's pretty well understood, I think.
Yeah.
The applications, go ahead, Scott.
No, finish your point, Nate, please. Sorry.
Of the applications compared to deburring, blending, polishing, finishing, all those others, grinding is probably the best universally understood.
Yeah, I would agree. I would absolutely agree with that relative to the others. In fact, we'll have a fun discussion on some of the others here coming up. But I do see people use the word grinding when they're actually finishing, for example, because they use it. If I'm going to use an abrasive, I'm going to call it grinding. That is actually quite common. And, they'll call grinding wheels. And, it might be a really light duty finishing product, and they'll call it a grinding wheel, for example. So grinding is a term used pretty broadly, but I completely agree with Nate. It's probably the one most consistently, accurately represents what the customer is trying to accomplish, but not all the time.
Yeah. Just one of the subtleties that I have there too is, if you're allowed to leave a step, or you want to mate two surfaces, sometimes that overlaps with blending, and then we get into, is it blending or grinding, and then how much parent material are you allowed to remove and stuff like that. So that's where we have some fun with trying to pinpoint that practical touch of that one.
Michael, we've actually, because this is such a common issue and such a misconception and misunderstanding is so common here when people use a given word and we make the assumption that this is what they mean by it, and it's actually not, that we've actually come up with 7 processes that define pretty much 99.9% of the industrial abrasive world. And it starts, and I'll just name the 7.
Yeah,
and then
let's go.
we can talk about any of them, but maybe from the most aggressive to the least aggressive. It starts with cutting, and we would, cutting is, I think, hopefully obvious. We're separating a material from another bulk material. Then it gets to grinding. Then we do, I can't remember if I think we had deburring next, then then cleaning, then satin finishing, orbital sanding, and polishing. So those were the 7. And you'll note there's several terms not included directly in those 7 terms, but they're subsets, and we can get into Buffing is a great example, but we can get into those terms as well. So we think there's literally 7 that pretty much describe, like I said, the by far majority of the applications in the abrasive world, industrially.
So you had an order. What was the thought behind the order?
Yeah, the kind of implied aggressiveness.
Okay.
When Nate talked, for example, Nate talked about grinding tending to be things like 36 grit abrasives, which are really coarse abrasives. They can get even coarser than that. And they're very commonly used for grinding. Why? Because number one, typically the most important aspect of grinding is speed. How fast can I remove material? And so we tend to go with larger grits. But you're tending to not do that if you're looking to finish, as an example. So we start with the coarsest: cutting, grinding, deburring, cleaning, satin finishing, orbital sanding, and polishing.
Okay.
And polishing is the least aggressive.
And that's also the most ambiguous.
Yeah, I was thinking that too.
Deburring's not far behind, but polishing and deburring to me are some of the two most, I don't know if misused is the right term, but ambiguous is probably best.
Yeah.
Terms used in the material removal world.
Often I'll hear polishing when you're removing machining lines. So that can be pretty aggressive process, right? Absolutely. It's not that other end of the spectrum.
Absolutely. And so, I would argue that within the grouping, we actually have 3 finishing categories. We would call satin finishing, orbital sanding, and polishing as all finishing, meaning the purpose is to generate a specific appearance in the part. And so polishing is absolutely used for almost the entire spectrum of abrasive processing. I've heard it used for the entire spectrum. And so it is the most ambiguous for sure of all of these, because it is used. But when I think of polishing, I think of generating a reflective high gloss surface. And so for me, that's generating a polish versus a satin finish, which is much more around generating a specific, consistent, linear, typically linear, can be curved, but usually linear scratch pattern of a certain RA level is quite common. In orbital sanding, the other finishing category is generating kind of this matte, non-linear surface finish on a part. Now, it doesn't mean that that's the last step. For example, orbital sanding is incredibly common as a way to prep a part for a coating that follows. It just depends on the customer's requirement. But for that particular step, the objective is typically generate a matte, non-linear surface finish on a part. So anyway, the category of finishing is pretty broad.
So the most ambiguous, you said, was polishing. I think, Nate, you said the second is deburring.
I think deburring follows that up, but I mean, finishing is also in there.
I've seen some applications for deburring where we say that's not a burr, you got to grind that down. So
yeah, I mean, it could be beveled.
We've kind of classified burrs to help us say, okay, can you remove it with your fingernail? Do you need like a tool to remove it, or do you need a power tool to remove it? So we kind of broke that out just to kind of get a taste for how heavy of a deburring job is some of those.
Yeah, so it's not that different of there's different levels of burrs, and you say the one you can just wiggle back and forth and break it off as a pretty light one. You've got, like you said, like a fixed blade cutting tool, like a deburring knife is a kind of a next level. And then something that is still a part of the parent material, so it's not something that you can bend. You can't knock it off with a knife. It's got to be ground off. Now that could be ground off using a deburring wheel and leaving a radius of some sort, or it could be as aggressive as using a fiber disc. So it's kind of a wide range there.
Yeah. And the targets aren't bad. Normally we either see a chamfer or a break edge or a round edge, right? And then you could have different specifications on the dimensions of your round edge, and there's lots of ways to measure them too. So that can get that could get fun. How far down the rabbit hole you need to go there to make sure you're hitting your quality targets too.
Yeah, there's
Exactly.
minimum, maximum radiuses. And what's the reason? Is it for personal safety? Are people cutting themselves, or is it a sharp edge for the people that are assembling parts? Is it aesthetic for the appearance of that part once it's sold to the end user? Is it functional? In an aerospace component that sees high stress, is there a minimum radius that has to be generated so when they shot peen it doesn't create flat spots and cause stress risers? So there's a lot of different ways you can call it out and characteristics of them.
So grinding, cutting, grinding, deburring, then cleaning, was it?
Cleaning, yeah, cleaning.
So define cleaning for me.
Yeah, great question. So, we generally look at cleaning as a removal of an unwanted coating on a surface.
Okay.
So, we're not necessarily talking about a conventional way to clean, but for us, this is about could be removing rust, removing any type of oxidation, obviously including rust. Could be removing scale is a common one. Soft coatings are common as well. Could be removal of paint, could be removal of a sealer. Nate, any other ideas of film? Any coating that you want to remove from the surface, pinstriping, any coating you want to remove from the surface, and you want to have you don't want to necessarily remove a bunch of bulk material. You just want to primarily
or corrosion or something, some contaminant on the surface that you want to take off without grinding away the parent material.
Right. Yeah, the key there, you don't want to remove much parent material at all.
Exactly.
Yeah. It sounds like we could have another 7 podcasts breaking down each one. Yeah. If you guys have, I don't know if you have on your website your classifications, we could put those in the show notes if you do.
I'd be happy to. Yeah, we'd be happy to provide that. So we'll do that. Yep.
Right on. So the next section, the next topic for us is, just to have a little bit of fun and, what sparks a passion for you guys in finishing? Do you guys have any hobbies that you bring home and you get into, or is there any things that you see going on? Wow, okay, those guys know their stuff. What sparks it for you? I can start off maybe with a little bit with mine. I've got. There's 2 things that I got into. I grew up on a farm and so there was always tools lying around, and we were always improvising structures and stuff like that. So I got into making furniture, and I like improvising the materials. So I'll someone will leave a pallet on the side of the street, and I'll take that and turn it into a nightstand or something like that, and to finish that so that my wife will actually put her cup of water on it, it's got to be finished quite nicely. So I got into, many of those steps there, from the heavy end all the way down. I had to figure that out for that. And then one of the things I love too is the joining and the different techniques. I don't go hardcore where I strongly believe in power tools. So I know there's some wood finishers out there that no power tools or fasteners allowed. I'm not that hardcore, but I love, the look of turning the furniture inside out. So you see the joining, and then the way you finish that, it highlights those, the dovetails or the different, the joining mechanisms that you have. So that's something that, that the overlap between work and hobby, that's where some of the passions lie for me.
Sure. I can go into what I play around with. So I've got a machine shop at home. So as a pretty young kid, my dad built street rods. So built cars, 30s, 40s, 20s, different years. So with growing up, there was always, that's what I had around.
Okay.
He had an auto shop. So I'd play with cars. Then I started my own little machine shop. So I've, machined parts out of aluminum, stainless, carbon steel, for cars for performance parts. And then when it comes down to the other side of machining car parts, it's also just working on cars. I mean, pretty much anything with an engine, 4-wheelers, lawnmowers, whatever it is, engine repair, painting, welding, fabrication. It's just kind of all of those. I would argue probably everything on that list has fallen into something that I've done in my shop.
And what do you have, like are you like a rat rod type of guy, or are you the flame on the hood, the super shiny surface? What kind of style are you?
Get it on the road, get it running and
Yeah.
trustworthy, and then I start moving on to the next thing.
Okay.
So they
Okay.
actually, the ones I've got now are painted. For a while there, they were just in primer, but they're fully painted now. Not much for interior on the one, but
Okay.
What's the old one, Nate? I remember.
That's a 31 Ford.
Oh, nice.
Model A.
Drives it into work on occasion. Only in the summer.
396 and a 5-speed, so it's far from stock at this point.
Really nice. Really nice. We've got a guy in the shop here. He's a 20-year project of his is, I think it's a 1968 Porsche 911. And it's been in his garage for 20 years, and he's been chipping away at it. And he says this summer it's the time it goes on the road. So we're planning a big party for that.
Very cool.
Yeah. So that maybe.
Yeah, that is. My father had a similar car. He bought it in the mid 80s, and
Okay.
it finally hit the road in probably 2010. He built dozens of other cars, and that one he just sat on and waited and waited and waited, and it was a cool day to see it finally go down the road.
Yeah, for sure. How about you, Scott?
Well, you talk to the number one guy in Nate, and so my interests pale in comparison. Obviously, I do historically I've done a lot of woodworking as well, but lately far less of that. I would say if you go into my shop here, you'll find an incredibly broad range of abrasives, and I would say most of them used in the cleaning category of some type. Just crap around the house, prep prior to paint, rust removal, removing certain coatings, and so more kind of a general utilitarian approach to using abrasives on almost anything that needs to be fixed up in some way. So, but I will say that in our application engineering team in the U.S., there is no doubt that we could that our team members could literally build a car from scratch. We have engine guys, transmission people, we have body people, we have hot rod people like Nate. I'm convinced we just get the parts and they could put pretty cool.
Figure something out.
Could figure something out. Yep.
That sounds like a good summer project.
Yeah, we should do that. It's like we could compete against the other 13 robotic labs around the world. Yeah. So you could build the coolest vehicle.
You ever watch the show Sleeper Car versus Supercar? Have you heard of that one?
I have not.
It's the garage.
I want to say my son has, but I haven't seen it.
It's garage enthusiasts, and then they put their cars up against a supercar, like a Lamborghini or a Ferrari, right? And there was one guy I'm a minivan guy, right? So I love my minivan, but one guy tricked out a minivan and he went up. He didn't do well. It was pretty heavy, but that sounds like a good contest for you guys to go into. Right?
That would be awesome.
Yeah. So the last thing, that we had on our list, the tough stuff, I used to go to, back when we could travel, eat freely, and roam freely. There was one machine vision show that I would go to, and one gentleman, he would always host my greatest fail. Yeah. Well, the biggest fail and or the craziest thing that you saw. So the one that I'll share was, I got called to a customer and said, you know what, I've got a heavy application. I think he classified it as grinding or could have been cutting, and I want to see if a robot will take care of it for me. And he led me out into his shop and then out back into the yard, and he had a backhoe with a chain wrapped around and a big casing on it, slung on it, and a huge abrasive wheel, and the driver was ramming the casing into the grind wheel and knocking off material using a backhoe. And I'm like, okay, that's a pretty serious. There's probably a robot that can handle it, but I was just blown away. I'm like, okay, I wasn't expecting something of that scale that you'd be looking to accomplish. There was no way they could do it by hand. And their solution, they were pretty innovative. Their solution was to rent a backhoe and use that to pick it up. And then that's the way they were producing that part while they were trying to figure out something more elegant.
Huh.
Wow.
Your face
Can't
is
say I've
priceless,
seen anything
Nate.
like that.
Nobody, yeah, that was my craziest one. Yeah.
Yeah,
But he's
honestly, I'm trying to think of. I'm not saying that I've never failed in my life, but I'm trying to think of a good fail that, you know, a lot of them are. They don't. It's not a catastrophic fail. It's more of a slow process that just didn't get implemented. Boy, I tried to come up with some before this, and I struggled.
Yeah,
well,
that's good
maybe.
news.
Well, yeah. So I'll just make a quick couple comments. Number one, definitely have seen some amazingly significant robots handling very large parts or
Yeah.
very large abrasive equipment. Nate mentioned literally manipulating a backstand as an example, or a gigantic part. Those are really fun to see, and it sounds like some people like your friend, like your
Yeah.
customer, figured out a path to manipulate this extremely large abrasive wheel and part. I will say the one area of failure that I've witnessed was, customers investing, frankly, a significant amount of money in robotics, but going, I don't want to say cheap, but taking some of the equipment, backstands, for example, and putting in relatively low horsepower motors.
Yeah.
They tried to save money in areas that killed them at the
Yeah.
end of the day, because they could not get the productivity out of the abrasive that they could have had they put in the right horsepower motors. Speed is huge. Speed and force for grinding, especially if you're grinding, speed and force are the two biggies. And if you don't build your equipment with enough oomph to deliver that speed and force, whether it be the backstand or the robot, ideally the combination of the two, you're destined probably to fail. And so it's tough to see that, but inevitably, they don't get the value out of the abrasive, et cetera, et cetera. So it's just an overall challenge. So retrofitting something like that can be challenging, but sometimes can be fun if the customer is willing to invest in the retrofit.
Yeah, I mean, I think we as 3M, as a prototype lab, we don't get, as directly involved. We work with end customers all the time, but I think it tends to be the integrators' interaction with the end users that have the bigger failures. More in the lines of trying to implement a process, and like Scott mentioned, of something that's not implemented appropriately. That they see that. Now, we might see it as an end result later, but we don't get directly involved as much in the design of that cell. So that tends to be where the separation between the application engineering at 3M and the integrators kind of hand off. And we'll work with it throughout, but we don't always get consulted throughout. It's okay, yep, we know what we have to do. Kind of an integrator may go off on their own, start doing it, and then all of a sudden at the end you realize, oh, you need to change this and that, and they're like, it's too late.
Yeah. No, that's a great point. This is our 26th year. So, to say that we've never had tough projects, as an integrator, we do things turnkey, right? So that means we don't let a customer down. So sometimes we do things gracefully, and there's been times where it hasn't been graceful. But I tell you, we've never let a customer down. And that's an important part. And so that's, people looking to get into robotics, look for those folks that have had that experience. That's certainly an important thing. So what you guys are doing, with the robotics labs, building that experience and helping customers educate themselves, and your list of integrators that have been around the block. That's so important, and for a customer looking to dip their toes in the water and see what improvements they can make.
Yeah, the lowest price isn't always the best deal.
Yeah.
And when people don't
absolutely.
know what they don't know, it's a dangerous world to play in.
Yeah, for sure. Well, with that, guys, I really appreciate you coming on. It's been a fun conversation, and thank you for joining us.
Certainly my pleasure, Michael. Great to be with you today, and it really was a fun discussion.
Yep. Thanks a lot, Michael.
Yeah, thanks, Nate. Thanks, Scott.
Take care.
So this concludes the episode of Robotics for All podcast by AV&R. If you don't want to miss another single episode, don't forget to subscribe to our show in your favorite podcast app. Thank you very much, everyone, and we'll talk again soon.